Today we will talk about exploiting authentication-based vulnerabilities. If you haven't looked it recently, check out the WASP Top 10. At the top of the list from the 2021, it's a broken access control. It moved up from the 5th to first place since 2017. This tells us that authentication-related vulnerabilities are a big problem. An attacker can bypass authentication in vulnerable systems by using several methods. The following are the most common ways to take advantage of authentication-based vulnerabilities in an affected system. It's credential brute forcing, session hijacking, redirecting, exploiting default credentials, exploiting weak credentials, exploiting Kerberos. Session hijacking. A web session is a sequence of HTTP requests and the response transactions between a web client and a server. The process includes the steps illustrated in this figure. It's pre-authentication, authentication, session management, access control, and the session finalization. A large number of web applications keep track of information about each user for the duration of the web transactions. Several web applications have the ability to establish variables such as access rights and localization settings. These variables apply to each and every interaction a user has with the web application for the duration of the session. For example, this figure shows a Wireshark being used to collect a packet capture for a web session to CNN.com. You can see the different elements of a web request, such as GET and the response. You can also see localization information, in this case in a cookie. As you learned early in this module, applications can create sessions to keep track of users before and after authentication. Once an authenticated session has been established, the session ID or token is temporarily equivalent to the strongest authentication method used by the application, such as username and the password, one-time password, client-based digital certificate, and so on. Note that a good resource that provides a lot of information about application authentication is the WASP authentication cheat sheet available here, and also we are working in PortSwigger. In the PortSwigger you also can find the several types of cheat sheets. In order to keep the authenticated state and track users' progress, applications provide users with a session ID or token. This token is assigned at session creation time and is shared and exchanged by the user and the web application for the duration of the session. The session ID is a name-value pair. There are multiple mechanisms available in HTTP to maintain sessions state within web applications, such as cookies in standard HTTP header, URL parameters, and the rewriting and the URL arguments on GET requests. Application developers also use body arguments on POST requests. For example, they can use hidden form fields or proprietary HTTP headers. One of the most widely used session ID exchange mechanisms is cookies. Cookies offer advanced capabilities that are not available in other methods. Here, this figure illustrates session management and the use of the cookies here. You can see here client, web server, open TCP connection between them, then post login user with the login Umar and the password bad password, then it creates session and attach cookie, then it returns web server return cookie to browser of the client, and then it sends request with cookie to the web server, and then after creating session and the attach cookie, it responds to the client. This session ID names used by the most common web applications development frameworks can be easily fingerprinted. For example, it's possible possible to easily fingerprint these development frameworks and languages by using the following session ID names: PHP SSID, GSE session ID, CFID, and the CF token. Also, this for it's recommended to change the default session ID name of the web development framework to generic name such as ID. The session ID must be long enough to prevent brute force attacks. Sometimes developers set it to just a few bits, but the session ID must be at least 16 bytes. Also, the session ID must be unique and unpredictable. It's a good idea to use a cryptographically secure pseudonym number generator, because the session ID value must provide at least 256 bits of entropy. Sometimes the session ID is included in the URL. This dangerous practice can lead to the manipulation of the ID or session fixation. Web development frameworks such as PHP, Ruby, Rails provide their own session management features and associated implementation. Note: it's recommended to use these built-in frameworks rather than build your own from scratch, since they have been tested by many people. Unfortunately, when you perform pen testing, you are likely to find people trying to create their own frameworks. This is pretty obvious, but you have to remember to encrypt an entire web sessions with HTTPS, not only for authentication processes where the user credentials are exchanged, but also to ensure that the session ID is exchanged only through an encrypted channel. Using an encrypted communication channel also protects the session against some session fixation attacks, in which the attacker is able to intercept and manipulate the web traffic to inject or fix the session ID on the victim's web browser. There are two types of cookies: non-persistent or session cookies and the persistent cookies. If a cookie has a max age or expires attribute, it's considered a persistent cookie and is stored on disk by the web browser until the expiration time. Configuring a cookie with the HTTP-only flag forces the web browser to have this cookie processed only by the server, and any attempt to access the cookie from client-based code or scripts is strictly forbidden. This protects against several types of attacks, including CCRF.